and then move on. When you post the video, it'll be there.
It's recording. You become a little bit complicated in this test, eh?
And we haven't even started the math yet.
Do you believe this part is hard? Hold on.
What part?
What part? Test number 3.
Oh, not horrible, but maybe harder than it's
Okay.
it's
Sorry. I told you at the beginning. And this is on the chapter, last chapter is more hard. It's hardest than this. So now, okay. So let's move on to question 10, no? 10, right?
End of 9.
Oh, we were finishing 9. We were at the part where you were.
Okay. I set out the integral at 9, and the only thing I need to do is the solver. Calculus 2, calculus 1. Okay?
No, you need to get the bounds. I don't think we got the bounds for the integral yet.
Yeah, we set up the equation. We just didn't put the bounds.
Very well. I set out the integral. So at 9, hello. At 9, we finished like that. Integral. I copy rho squared sine cubic phi cosine theta sine theta the something the rho the phi the theta, and the limit was 0 to radical 2, 0 pi over 4 is a phi, and 0 pi over 2 is a theta. Well, the rest is separate. This case is super elementary. In this case, separable.
Professor, by the way, last time you told us it was phi over 4, not phi over 2. Good power 2.
Phi over 4.
No, phi to the power of 4.
What do you say?
Yeah.
The last it's pi over 2, no? Pi over 2, pi over 4. It's okay or no?
No, I meant the p.
The row.
Row to the 4th.
Ah, to the 4th. All right, let me see. Pi to the 4, to the 4, to the 4. Yeah. To the 4. You're right. To the 4. Yeah. To the 4.
And is the sine phi? I thought it was supposed to be squared.
No, because you have another sign, no? Sine and sine.
Yeah, that's right.
Remember,
remember
the integrand function is the multiplication x times y, no? And x is rho sine phi. That is the reason. Actually, we have 3 sine phi. The sine phi of x, the sine phi of y, and the sine phi of the Jacobian, no? You follow me or no?
Yeah, I follow.
Okay. And this is 0 to radical 2, 5, 4, 0. Something like that, right? Okay. So the rest is Cal 2, and Cal 2. And the final answer is 4 radical 2 minus 5 over 15. When you perform 3 integral and multiplication each other. Cool. Okay, I want to erase everything. I go directly to the question 10. Good or no?
Good.
Okay. Question 10 is similar. Question 10 is similar. I give you one integral. You need to understand the idea behind this integral. So how one hypothetical students set up this. So this is from square root x squared plus y squared. This is very, very similar. Very, very similar. No complication. This is changed a little bit. And this is -1 to +2. It's a given. I need to change to a spherical coordinate. First of all, I need to understand the solid and the projections. The solid is obvious, is a sphere. Okay, this is C in between radical 2. This is exactly the same, the other problem, the previous problem, the same solid. Not the same, similar. Okay. You know very well that this is a sphere or hemisphere of the radio radical 2, no? And a cone. So this is hemisphere, radical 2, and radical 2. And we have a cone. And this is apparently, this is our solid because the student can set out this integral is doing from the C value of the cone, is this, to the C value of the sphere. Okay, of course we have here the intersection curve in between this. Okay, now the projection in the XY plane is a circle. Is that circle. Okay, that circle is the intersection. I did before this problem. So this part is radius 1. Okay, 1, 1, -1, and -1. How do you know that? When you put together this equation and this equation, you get that. So you get x squared plus y squared equal 1. The students que set out this triple integral finish that doing the double integral in that region. And that region go from the negative part of the circle and the positive part of the circle. Look. This is the y value. Y equal negative something, y equal positive something. And finally, extending the strip from -1 to +1. Okay? Super easy. Super easy. Now, when you convert in triple integral, spherical coordinate, don't forget Jacobian, rho squared sine phi. Now, don't forget also the integrand function. The integrand function is the part here inside the integral, no? Que es 1 over z square root x squared plus y squared plus z squared. I know very well. See, so I need to know the conversion equation from Cartesian to spherical, no? It's rho cosine. So you replace, no see anymore. And square root x squared plus y squared plus c squared and rho. Actually, we have rho cosine phi. This is phi, sorry, not theta. Phi. And another rho. Of course, the rho, the phi, the theta. Okay, according to the other view, I forgot to say, for example, this view, okay, it's a sphere, this is xc, 3D, 2D, and another 2D. Okay, the solid look like that. And it's obvious that rho vary from 0 to the rho of the sphere, que es radical 2. And phi vary from 0 to pi over 4. And theta vary from 0 to pi because the full circle. Wait. Entonces now, in the integral function, I forgot to say, que obviously rho squares cancel, and sine divided by sine is tangent phi. And the rest is computation. This is extremely easy. It's separable again, 0 to pi, d theta, integral 0 pi over 4, tangent phi, d phi, and integral d rho along 0 to radical 2. Entonces, the answer of this, you separate this, calculus 2, 3 times is 2 pi radical 2 natural logarithm of radical 2. Now, a confusing question. Let's say super easy. Super easy. No big deal. Question. No? Follow me.
Just one question. So how did we convert the equation, like the z, the 1 over z square root of x squared plus y squared plus z squared? How do we convert that into the...
Using the formulas. What formula? The formula of the...
of x, y, and z?
P squared.
Es x, y, and z. X is equal to rho sine phi. So the formula is the formula for the conversion from Cartesian to polar Cartesian, spherical, sorry. Cosine theta, rho sine phi, sine theta, and c is rho cosine phi. And you know que rho is square root x squared plus y squared plus c squared. Correct?
Oh, okay. Yeah, correct. Okay, got it.
There, so basically, a ver si you understand or no. We have is given one integral in Cartesian. I need to change to polar. So you use the equation of the conversion from Cartesian to polar. To polar, not to spherical. Coño. And also, don't forget Jacobian, and don't forget to understand the solid and conversion to spherical and set out determining the limit. Okay? This is central idea. And the other formula that you copy in your moment in the lecture you have in the piece of paper. No? Okay, 11 now. 11 now. Erase.
Yeah, I think everyone's got it.
Okay. Number 12. Number 12, no, 11, no?
You mean 11?
11. No, 11 is easy. It's around the double integral. In this case, double. On the region bounded by the, it's giving some curve, no surface curve, because it's a double integral in the plane xy, dimension 2. Entonces, x squared plus y squared equal 4 as a circle, no? And x squared plus y squared equal to y. It's another circle, but with some translation. Okay, entonces now basically two circles. And C is greater than or equal to 0. In the first quadrant. Entonces now, the function, the function is hypothetical function. So it is easy, super easy because it's hypothetical function, x comma y. So I need to set up this double integral in the region R. dA, like that, generically. This is equal C. So basically, the only thing I need to understand is the region R. Because the C is hypothetical function. Well, first of all, it's a circle. Center, origin. Radio 2. No problema, ¿verdad? 2, 2, negative 2, negative 2. This is another circle. But to understand much better this another circle, you complete the square. And the magic number que complete the square is 1, no? Is 1. Therefore, x squared plus y minus 1 squared equal 1. This is our circle. It's easy. The radio is 1. And the center is located at the point 1,0. No, 0,1. 0,1. 0,1. Here, over there. Over there. This is our circle. Radio 1. Okay. In the first quadrant, in the first octant, to say it, octant, first octant. Octant means okay, everything is positive. X is positive, Y is positive, and also C is positive. Entonces es bonded, no? The information that's given is bonded. This is bonded. Bonded by this, I suppose que es inside. Well, in this case, it's inside the big circle and outside. Bonded. Makes sense it's bonded, no? It's that part. This is our region R. This is R. That one. Correct? Ya need to compute the volume. This is a volume, no? Because the integral function is the hypothetical integral function. So far it's clear? Now ready. This is the double integral, pero es obvio. When it's obvio, no, we can do in Cartesian, pero it's much better doing in polar, no? Because it's a circle, no? It's a piece of circle. Now, the integral function is f, is the name, but x is r cosine theta. Use substitution, r sine theta. End the story. This is x, and this is y. And the Jacobian is r dr to theta. Correct?
Yes, correct.
Now. The limit is, look, make a zoom, the region. In my opinion, is in, what the hell is that? In polar is that direction. Okay, let me make a zoom. The zoom is the radio go from this to this. It's obvious it's a variable. For example, in this case, it's a variable, but in this case, no, it's a constant. No? It's a constant. So go to the radio of this circle. To the radio of the other circle, que es 2. That the upper limit is 2. It's clear this idea, no? The other no, the other is not clear. But I go to the equation, this equation. I convert this equation in polar. X squared plus y squared is r squared. 2y, who is y? R sine. Cancel out at least one r. R is equal to sine. Okay, so I go to the r of the first circle, que es the small one, que es variable, so depending of theta, of course. 2, 2, 2, 2, 2, 2, 2, que es the constant radio of the second circle. And it's obvious que theta go from 0 to pi over 2 because my region lie in the first quadrant. End of story. It's a volume. The question, no specification, can you convert to polar? No? Oh yes, set up the double integral. You can set up in Cartesian if you want. Either way. But I suppose it's better in polar because we are, you know, when the region is bounded by the circle or piece of circle, it's better. Any question? And leave it like that because we have no expression for the f function. Cool?
Professor?
Can
you go over the lower bound for the dr part of the integral one more time?
Okay. And do you see the area? I make it soon, right?
Yeah.
You go, mister, from this radio. Let me go R1 to this radio. This is a radio 2 in green color. Radio 2 is obvious que 2. Radio 1, no. It's not constant. It's variable. Is the R of the small circle. I prove mathematically that the R of the small circle is that guy. Cool?
I thought the R was 1 for the small circle.
No. This is the radio. I agree 100% with you that the radio gets the distance from the center to any point on the circle one. But R and polar is measured from the origin.
Yeah.
Yes or no?
Yeah.
Any other question? Okay, so let's move on to number 12.
But how'd you set r squared equal to 2r sine theta? Like that's where.
Okay. Repetition again for you, mister. Look, I take the equation for the small circle, que es this. Yeah, I know very well the equation can allow me convert from Cartesian to polar. The equation are x is equal.
So you just want the polar and then.
Yeah. I need to rewrite. See, I make a decision to build the same integral, but I change the variable to polar. I need to change everything to polar. X, Y, no XY anymore. It's R, theta, something, right? Okay, entonces I did this conversion here. I know the formula que r square es x square plus y square. I know the formula que y alone is r sine, no? Plugging in, replay here. I discovered that one r is cancelled. Therefore, r is exactly that distance. R1 is 2 sine theta. Make sense?
Yes.
And it's not constant. It's variable because depending on the position of the point, no? Okay, number 12 now. And number 12 now, we have compute the volume again of the function. So the function is given, ¿no? Entonces es, wait. Day one volume. Entonces now we compute double integral or you compute triple integral. What do you think? Si the integrand function is given, ¿no? Entonces the compute the volume below that function is given and above the xy plane. Okay, cool. Okay, and that means C is greater than or equal to 0. Bounded but between two cylinders. X squared plus y squared equal 1 and x squared plus y squared equal 2. Oh, it's easy. This is my solid, no? My solid is this and this. Bueno, no exactly. This is the region R. This is the region R. The solid is more complicated, no? But I don't frustrate with this because I don't need to do anything in 3D because I suppose that the height of this solid is the function, no? So now I focus in the region. The region looking in the XY plane is two circles. One circle is radius 1 and another circle is radius 2. 2 and 1. And this is my region. My region is the ring. One more time happen, que the polar is the best option. But do you understand que es doble integral, right? Doble integral. Suppose que I set up the doble integral. A cartesian is doble integral in the region R. Okay, by the way, this is the region R of this function que is y squared divided by x squared plus y squared dA. I indicate like that because I don't know si I integrate in this direction or integrate in this direction. Or integrate in polar, que es like that. I suppose que it's better, right? In polar, eh? It's obvious, right? See, in polar, we are doing step by step. Step number 1, changing integrand function in polar. Bueno, I know que x squared plus y squared is r squared. Y I know que y alone is r sine theta. Therefore, y squared is r squared sine theta divided by r squared. And r squared is cancelled. Wow, entonces my integrand function is just sine a squared. I forgot the here is square because there's square here, and a square here.
Also, Professor, isn't the second circle radius square root of 2?
Yeah, you are right. Yeah. You are right. This is square root. Exactly half in my paper. Okay, ready. So now, the rest is piece okay. The rest is important. My integrand function is sine squared. The Jacobian r dr d theta, as always. And the radius go from 1 to radical 2. And theta go from 0 to pi. Super easy, super easy, super easy. And this is separate variable. Cal 1, Cal 2. The answer is pi over 3. Cool? Any question? In this case, volume using double integral. Are you clear the difference of the interpretation of the double integral to compute the volume and triple integral to compute the volume or compute another thing? Are you clear, right? Definitely you.
Can you go over that one more time, Professor? Because I get how the triple integral shows volume, and it can also show.
I remember when I teach in the lecture of the double integral, you say, what is the meaning of that? You say, it's volume. It's obligate volume, right? It's like when you, in the double integral, you include integrand function, it's obvious that the answer is volume. Because interpretation. This is my region area R. I chop that, I multiply by the one hypothetical surface. Okay, this hypothetical surface is this function. Entonces es obvio que es the volume, no? However, we can compute the volume using triple integral, of course. But in this case, when you put the triple integral, the integrand function is 1. Okay, it's also volume. En the scenario que no 1, entonces ese más. O sea, you are doing like artificially, que si you suppose que the density es 1, entonces there are numerical coincidence in between volume and mass. That si you ask me, what is the natural? I don't want to use in this word. Natural meaning of the double integral, one is the volume. I see natural because I multiply by x as momentum, you know. Pero the natural, without only one function. And what is the natural meaning of the triple integral? Oh, ese más. However, I make coincidence, numerical coincidence. Because when the density is 1, entonces es one solid whose mass is equal to volume. Now it's clear now?
Sí.
Beautiful. Guys, this concept is repeated throughout the course. In the chapter 4, we see another kind of integral. We don't finish the integral. In vector calculus, in which, when the integral function is 1, change the meaning. This is classic. 13 questions. 13 questions say 3x plus 4y plus c equal 12. Okay, the questions say compute the volume below this, que es a plane, no? As okay, the volume is below the plane and c equal positive only. Above this, no? And it's bounded by the region x squared plus y squared equal to x, no? And by the way, we compute before, no? We complete the square, right? It's similar. So when you complete the square, you get x. No, but it's different. It's x squared plus 2x plus box plus y squared equal box. The magic number to complete the square is 1. Therefore, this trinomial is perfect square. X plus 1. Plus 1? Plus 1 or minus 1? Plus, no? Plus? X plus, no? Plus 1. X squared plus y squared equal. Es de... Let me see. ¿Es plus o es minus? Es plus, ¿no? No, hello. Es minus here. It's minus because I moved this guy to the other side. Nice. And it's a minus. So this is the cylinder, in 3D. is the cylinder with the center is located at the point 1,0. Okay, let me try to understand the picture. The picture is 3D picture. Okay, we have a plane. Okay, I have no too much idea. Well, I have because you apply intersecting. For example, you could declare y and c0, 3x equal 12, so x is equal 4. 1, 2, 3, 4. This point is 4, 0, 0. Belong to the plane. So you declare x0 and y and c0 is 3. 1, 2, 3. This point is a point 0, 3, 0. And finally 12. Ooh, 12 is too long. Okay, no problem. 12. 12, 12, 12. I suppose hypothetically this is 12. 0, 0, 2. Yeah, at least this is the piece of the plane. It's a triangle formed by the plane, that plane inside the first octave. The first octave. Okay. The problem say first octave. Yeah, a little bit. First octave. Now this is y, this is x, this is c. However, we have a cylinder. Cylinder gets center is in 1,0. Look at that. No. It's not first octave. This is continuous. So this is continuous in this direction and this direction, but not in this direction. So we have, let me use my imagination. We have cylinder, and this cylinder is something like that. And my solid, que is a little bit weird, is, I don't know, something like that. Okay. This is the face, the top face, que is the intersection with the plane, and the wall is the cylinder. Make sense? Of course, this plane extending in this direction, in this direction. No, in this direction. No, in this direction, because C is positive. Do you understand the solid or no? 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 Yes or no? Answer me, guy. Yes or no? Cylinder and plane is the top. Well, the top is plane and the bottom is another plane. Okay, C equals 0. Top, plane, inclined surface, flat. Bottom is C equals 0, another. Cool? Yes or no?
Cool.
Yes, sir.
Professor.
Okay. Albert.
So
Give me.
in the plane, you set x and z equal to 0 to solve for y, and then
Yeah. This is to have one roughly idea by hand of the plate. So you, for example, you declare y and c is 0. And the equation is 3x equal to 12. And you solve for x, you solve before, no? And the point is at least one point to satisfy the plane, 4, 0, 0. This is the classic idea how you determine intersecting. Okay?
and so the cylinder is behind that?
The cylinder is inside. Yeah. Okay, basically my plane formed in the first octave like a triangle, yes or no?
Yeah.
Entonces the cylinder is inside because the radius is smaller, the radius 1. But the positive part of the C, you extending over only touch the plane. And that's it. The plane cut off this face.
Okay.
Okay, ready. So now I need to compute the volume of this solid, right? The volume of this solid. The volume is, okay, no specification si es polar o no. Okay, no problema. The region R of the function, que the function es obvio que es the plane, ¿no? O sea, the function here es obvio que es the C of the plane. Makes sense, right? Because it's the height. It's the height. So you are doing, for example, in Cartesian, que I don't know, recommend, because the region, this is 3D, and 2D, XY, you see something like that. Okay, this is 1, this is 2, this is Y, this is my region, R. This R is this R. Okay? Entonces, I don't know, I suppose que es better, ¿no? To be in Poland, ¿no? O no, si you are doing Cartesian, no problem. Ok, entonces en polar, doble integral, this f of x, y is the c value of the plane. So you solve it. It's 12 minus 3x minus 4y. dy dx. Okay. Entonces now you integration in this direction. But this is the complication, no? Because this is you take this, isolate the y. So x squared plus y squared equal to x. Y squared is equal to x minus x squared. Apply square root, plus and minus 2x minus x squared. And you integration in the y direction from negative 2x minus x squared to positive 2x minus x squared. Do you follow me? Okay, now finally, when you extending in the x direction, you go from 0. This is set out in Cartesian. But I don't like this. No. Well, okay. See, no specification. You leave it like that, it's perfect. The disadvantage is the integration is more complicated because this limit, is horrible. No? However, si you set out in polar, well, okay, it's 12 minus 3 r cosine theta minus 4 r sine theta, Jacobian r dr d theta, and r go from 0 to the r of this circle. And the r of this circle is, look. You take this equation one more time. Is x squared plus y squared is r squared. And 2x is r cosine theta. Therefore, r is equal to cosine theta. So I go from 0 to 2 cosine theta. And theta go obviously from 0 to pi, no? Because, let me see, is pi or 2 pi? All right, when you're extending, it's from 0. Well, okay. From 0 to pi, and multiplication by 2. Take advantage the symmetry of the figure. Okay. Okay. Either way, this is too long process. Now the complicated part is the integration, that part. Of course, I did it in my paper. The answer is 9 pi. Okay. Okay. Finally, 14. 14, 14, 14. Okay. Do you understand 13? Or no? Erase, no? Okay. 14. 14, 14, 14. Do you see it intentionally? I shouldn't say that. But you seek it intentionally. The question in the test is exactly the same, twin brother, with the question of the review. Because I know that this is hard. Let's see, the only thing you should do is just copy it. My recommendation is when you copy, you try to understand by yourself, no? Much better, right? There are questions that no, it's different. But the question is similar, copy paste. Do you see or no? Answer me. Ah, entonces notice, I notice. Álvaro Herrera dice, I notice. Ajá, entonces, I suppose que I am no bad guy, ¿no? I suppose. Sometimes I behave no good. Okay, entonces now, the 14, que es the last one, compute this integral. I don't want the interpretation. I suppose que es the mass, volume, sorry, volume. Volume. And bounded by x squared plus y squared equal to x. It's a circle that I did before, no? And y equal x, that's the line. So that circle, we complete the square, guys. And the answer is x minus y squared plus y squared equal 1. Okay, let's do in the region. The region is super easy. The region is, we have a circle, that circle, radius 1, center 1. And we have the line be set, y equals x. I suppose, okay, this is our region. This is our region. This is our region. This is our region R. Pues es bounded, no? Somehow. It's obvious, no? Because maybe you say, well, why not the other part, the majority? Well, I suppose que es this. It's below the circle and above the line. See, you suppose another region and you are doing well. I do not specification well in the test. I accept the answer. Okay, now, what do you think? Cartesian or polar? Let's do it in both ways. Okay, suppose one student can say, no, I don't like polar. I want to do a Cartesian. So why? Entonces the direction of the integration, maybe we are doing in that direction. No? Let me make a zoom to see more clear the region. And I set out the double integral to compute this volume or something. I go, okay, this is the y dy, no? dy, this is the first direction of the integration, and the second is dx. I go from the y of the line to the y of the circle. And the y of the line is x, because y is equal to x. And the y of the circle, I did before, no? I did before, is is out integral from the y of the circle. See, I did that. The y is y squared is equal to x minus x squared. Therefore, y is equal to square root 2x minus x squared. Yeah, I take the positive part because my region is in the positive part. So I go to the radical 2x minus x squared. Okay, now you're extending this strip both direction like that. It's obvious that from 0 to 1. And you cover the region. This is a fantastic example in which, in my opinion, the region is circle. However, it's easy doing in rectangle. Okay, let's do it quickly. You integration that part first. Integration from x to the square root 2x minus x squared y dy is y squared divided by 2, no? Evaluate in between x and the square root 2x minus x squared. This is 1/2. Square this guy is 2x minus x squared minus square this guy is x squared. Actually, we combine like term. Why not divided by 2? The answer is x minus x squared. Okay, and so I put this function inside the second integral. Okay, is x minus x squared dx. Super easy, super easy. Antiderivative is x squared over 2 minus x cubed over 3. Evaluating between 0 and 1. And 0 is always 0, not always, but in this case. And the other is 1/2 minus 1/3. Okay, 1/6. Okay, and this is the volume for this. Suppose that some students say, no, wait. I want to do in polar. Okay, let's do it. And you see it gets a little bit more complicated than integration, but okay. Suppose another student que is fun to do the double integral in polar when the area, when the region, sorry, is a piece of circle. Okay, entonces now the integrand function es y, ¿no? Es y. Entonces y es r sin t. The Jacobian is r dr dt. Guys, you see it's mechanical, no? And this r and this r, why no? You can multiply. I don't know, either way you prefer. And so you multiply, this is square. Okay? And come back to my famous region. So when you are doing the integration in polar, remember the direction in polar is different. It's like that. The direction of the polar is like a piece of cake. And you open here in theta, and you open here in r. R, theta. So I go from 0 to the r of the circle. From 0 to r of the circle. From 0 to the r of the circle. But what is the r of the circle? I forgot. Well, the r of the circle is, remember this is the formula, no? The formula is x squared plus y squared equal to x. R squared is equal to r cosine. Therefore, r is equal to cosine theta. This is the r of the circle, 2 cosine theta. And theta, go. When you're standing from this angle, this is theta. Remember, theta is measured from x-axis, 45 degrees pi over 4. To when it's tangencing is pi over 2. Therefore, is from pi over 4 to pi over 2. Okay? Okay, cool. Cool. Do you understand this or no? This is the most important for me. Now, the rest is, you know, Cal 1, Cal 2. Go ahead. Question.
Could you explain how to do the angle part again?
Yeah. Let me try to do my best. Another sketch. This is the famous circle. This is the famous line. This is our region. Y I make a decision, integrate en polar. Si integrate en polar, my elementary of polar look like that. In green color. Green color. Let me try. No, wait a second. Green color. Green color. Okay, this is my infinitesimal piece of area, pero en polar. Remember, the infinitesimal piece in Cartesian is rectangular, no? dx, dy. However, my infinitesimal in polar look like a little bit curvy, no? This is d theta, and this is d. And the magic of the integration is when you integrate, for example, with respect the r, you stretch something like that. This is the thing I did. So it's clear that from 0 to the r of the circle, okay, I proved this. The problem is the angle. Okay. Our piece, okay, you open in theta. Okay, look at that. This is a crucial moment. You extending the green part from this angle, boom, touch, to this angle, boom, touch. Because the circle, you know, decreasing the radius, but it's tangencing to the y-axis. Entonces es obvio que es pi over 4 here and pi over 2 here. Make sense?
Okay, thank you.
Yes. Bueno. So now let's try to do by hand this, or no important. What do you think? No important?
Not important.
No important. Bueno, you have time. Si es no important, entonces now I start chapter 4. No? Do you want to start chapter 4?
I prefer if we don't like go over any new stuff, so we can take the test.
Okay. Yeah. Let's do it. It gets easy. In this case, the limit is not constant. The limit is not constant. So you need to integrate. You see, I bring this example to illustrate that not always when this circle in the region, the best way, I suppose 99% of the time is better in polar. However, this example, no. Because, you know, for example, to do the integration, the first integration is this. The first level of the integration is R. Basically, is 0 to 2 cosine theta. And sine theta is a constant. If you want, you put it outside the game. And you focus it in R squared dr. The answer is sine theta. This is R cubic divided by 3, evaluating between 0 and 2. cosine theta. And you plug in 1 0 es 0, pero tu cosine theta no. Es sine theta. And 2 cubic is 8 cosine cubic theta divided by 3, ¿no? Entonces, basically, is, let me copy in the more clear way, a cosine cubic theta sine theta divided by 3. Cool. Now you perform the last part. The last part is integral. It's doing here. Integral is doing here. Of a over 3 is a constant outside. From pi over 4 to pi over 2 of this function que es cosine cubic theta sine theta d theta. Okay, this is no big deal because that's the typical trigonometric integral. And we assume, for example, that u is cosine theta. And the u is derivative minus sine theta. Okay, so almost we have completed differential, but the only problem is that you put the negative here, and it doesn't affect you put negative here. Entonces, basically, my new integral after the substitution is minus a over 3, integral from something to something, I have no idea, u cubic du. Yes or no? Well, and what about the limit? Well, the limit is si theta is pi over 4, cosine pi over 4 is radical 2. And si es pi over 2, cosine pi over 2 is 0. So we have in trouble because the upper limit is smaller than, but we can using the property for the defined integral, you switch that and you change the sign. This is logical. A over 3 integral from 0 to radical 2 over 2 u cubic du. Entonces a over 3 and this is u4 by 4 evaluating between 0 and radical 2 over 2. Well. Let me try. This 4 and this 8 somehow cancel. It's 2 thirds. And you evaluate radical 2 over 2 raised to the 4 power. Que es 4 over, let me see, is 1/4. The 2 thirds times 1 over 4. No? Let me try it. Radical 2 to the 4 power is equivalent to say radical 2 to the 2 to the 4 power is 16 get 4. And 2 to the 4 power is 16. No? Yeah, easy. And reducing lowest term 1 over 4. And so the answer is you reduce here to is 1 over 6. You see is the same answer, beautiful. Double checking. What I'm doing in Cartesian and Polar. Sometimes it's horrible. Doing in the Cartesian. But in this case, no. In this case was a little bit, not too much easy. Do you understand, guys?
Yes.
Are you ready to take the test?
Yes.
Ready as we'll ever be.
Say again?
Ready.
Ready. You try to do your best. I did my best, I suppose. I failed in the document. I want to convert to PDF. I send back again. And then another email. And the email with the video. I want to send. Well, the rest of the time, 5 minutes, I want to talk something, right? To refresh your mind. No. The new chapter is fantastic. It's the best. It's a vector calculus. At least you know the name. Vector calculus. Vector calculus. You never see before in your life. Vector calculus. Some university offer Cal 3 to this part, que es múltiple integral, que we cover in the chapter 3, and separately another subject, que es spectral calculus. Okay? Now, extremely important because you need to use it in the engineer or science subject, like a fluid mechanics. Fluid mechanics is the one important subject engineer. Okay, you need to understand very well vector calculus. Okay, and electromagnetic. I promise that the last day I want to explain somehow about electromagnetic. Some university call it electromagnetic, another call it electromagnetic and weight, depending on the school university, no? And the most important concept in vector calculus is a vector field. A vector field. Okay, it's totally new mathematical object you never saw in your life. Vector field. What about vector field? Vector field is in few words, it's a function. It's a function in which you associate the points, maybe in 2D or in 3D. En 2D es de clásica x, y, ¿no? Y en 3D es x, y, z. You associate this point to the vectors, A vector, of course, like that. Let me show you. A vector, the same notation we're using, p, x, y, q, x, y. Who is pq? Okay, it's a vector. This is the first component, and this is the second component, no, of the vector field. P and Q both are scalar functions. Some book call it a scalar field. I don't like this because actually it's a function in 2 dimensions. The function we studied in the previous chapter is P and Q, okay, we can represent like a surface. But no, here is a component of the vector. Y en 3D es P, x, y, z, q, x, y, z, r, x, y, z. And you need to be familiar with these 3 letters that we use every day. PQR, PQ in 2 dimensions and PQR in 3 dimensions. Well, does it look like we are? Because what the hell is vector field? Let me try to show you to motivation. A vector field pictures of this vector field. But you don't worry too much because we have application to do this vector field. You don't worry too much. For example, vector field in 2D and vector field in 3D. I want, in the next class, of course, I want to do the sketch of the vector field by hand. But not important by hand because we have application in which you put the vector field you want and you can see. Entonces, en few words, a vector field is a bunch of vectors. So you associate any point, suppose this point, and one vector. Suppose this point, in 3D, one vector. Wow, easier to understand. Entonces now, this is the mathematical object that we're using in the chapter 4, vector field. And we study their property, their applications, okay, and any subject and engineer. Cool? Motivation, at least. Entonces we have class next Wednesday, no? Because Monday is holiday, no? Entonces, guys, good luck for you. I wish.
Thank you, Professor. Have a nice weekend. See you Wednesday.
Try to in PDF. No, don't worry for this. I switch in the Word document to PDF. I suppose I actually have this. Okay, guys. Bye-bye. Take care.